Hey folks, welcome to my channel Number Pen. So today we are going to look at the quotient rule in differentiation, right? So there we have the rule written for us on our screen, and we're going to look at how we go about proving this particular rule, which we will be using in solving a lot of problems in differentiation, right? So if u and v are two differentiable functions, then d by dx of u by v equals v du by dx minus u dv by dx, the whole divided by v square, right? So again, we will start off with first principles. And before I write my first principles, the assumption here is my f of x is equals u by v, and it's understood that u and v are functions dependent on x. So we're going to represent them as u by v here, but otherwise it actually means u of x by v of x, right? So let's move to the next line and write what is our f dashed of x, right? Which is my d by dx of u by v is nothing but my f dashed of x. That's my f dashed of x. And when I go to my first principles and write this out, I will have to call out my limits, which is limit h tending to 0, and my f dashed of x is nothing but f of x plus h minus f of x divided by h, right? And now that we have this expression in front of us, we know what is my f of x plus h, right? My f of x is u by v. So my f of x plus h is going to be u of x plus h divided by v of x plus h, right? And then my f of x is nothing but u of x by v of x, right? I still have my h in the bottom. I'm going to rewrite this expression which we just worked out along with limits. So my limit h tending to 0 of this expression, right? I'm going to do a cross multiplication here. And when I cross multiply and rewrite this expression, I'm going to be left with u of x plus h into v of x minus v of x plus h dot u of x divided by h. And I have my v of x into v of x plus h, right? So this is what we get, and all that I've done is cross multiplication. And when you do a cross multiplication, what really happens is your v of x moves here and v of x plus h moves here, and then you still have your v of x into v of x plus h in the denominator, right? So I'm going to rewrite this expression in the next line. Limit h tending to 0 have this, right? And right now my numerator has got a u of x plus h dot v of x minus v of x plus h dot u of x, right? So I retain what we have in the denominator for the time being, and I'm going to rearrange my numerator. I'm sorry, before I rearrange, I'm going to do a simple step which does not change the expression, right? I'm going to subtract and add a u of x into v of x, right? And that does not change my numerator, right? So this is what we have. So all that I've done is I've added and subtracted a u of x into p of x, and that does not change the expression in any way. And you know what I'm going to do next? I'm going to combine these two terms, and I'm going to combine these two terms because I do see a common factor, and let me highlight it in green. So on the yellow portion, I have my v of x as a common factor, right? So I'm going to write that out, and let us move to the next line. Limit h tending to 0, and when I write the yellow portion, remember folks, we are sitting on the yellow portion right now, so I can pull out my v of x, right? And I can rewrite this as u of x plus h minus u of x, right? Divided by, I still have this out with me here. And then I am gonna write this out for the green portion, right? I know that I have u of x as the common factor for the green portion. I open my flower bracket, and then I have a v of x plus h minus v of x divided by, I still have this in my denominator, right? Now my u of x, right? So on expression 1, right, which is this portion, right? Let me again use a color, the yellow color, and let us use green for this, right? I'm gonna rearrange this, and let's see what do we get. And I'm gonna move to my big brackets. Limit h tending to 0. I have my v of x common in the numerator and in the denominator. So I pick up my pencil, and I can cancel out one v of x, and let's see what do we do with the other. Folks, I guess there has been a small error. I think this is not a positive sign. I'm referring to the positive sign in between. Let me highlight this. This will be a negative sign, right? I'm going to break the yellow portion into two further parts, right? And what do I get? My first part is u of x plus h minus u of x divided by h. And my second part, and I'm using the algebra for limits, and I'm rewriting this expression as 1 divided by v of x plus h, right? So I can combine. So my u of x plus h minus u of x divided by h, limit h tending to 0, is nothing but my u dashed, right? So this part is my u dashed. I'm still going to use the yellow thing. And what is my second part? Limit h tending to 0, 1 by v of x plus h. Remember, folks, our assumption is u and v are differentiable functions, and therefore it also means that they are continuous, right? And we know that for continuous functions, limit h tending to 0, v of x plus h or u of x plus h equals v and u respectively, right? So this expression I can eliminate the h in this expression and rewrite this as 1 divided by v of x, right? And why is that? Because v is a continuous function and so is u, right? So my limit h tending to 0, v of x plus h is equal to v of x, right? So I'm going to erase this out and then straight away eliminate the h in that equation and call it a 1 divided by v of x, right? And similarly, I have a minus out here and I call out my limits, limit h tending to 0, and I'm going to pull out my big bracket. And what is my, I will have to do a bit of rearrangement out here. This equation is nothing but u of x, right, into v of x plus h minus v of x divided by h into my, again, going back to algebra of limits, I'm going to write this as h tending to 0, 1 divided by v of x into v of x plus h, right? I know that my v of x is independent of h, but my v of x plus h is a continuous function. And like we discussed earlier, we can write this as v of x into v of x, and I can remove my limits symbol here because my v is a continuous function, right? And I can write this as 1 divided by v of x square, right? Similarly, my u of x is also independent of h, right? So I can pull this out and I can probably, um, call this out here, u of x. And then this expression, right, let me highlight it by green, is nothing but my v dashed of x, right? So when I rearrange this equation, I'm going to move to the next line, right? My limit h tending to 0, u of x plus h minus u of x divided by h is nothing but my u dashed of x, right? So u dashed of x, let's start calling it as u dashed from here on because we have done most of the simplification that we need to. And I'm going to call it u dashed. Just a minute. And my v of x is v minus, I have a u of x out here, which I'll call it as a u. And then my green portion, which is v of x plus h minus v of x divided by h, becomes a v dashed of x. And let me call it v dashed of x. And then I have my v of x square is nothing but a v square, right? So now we have my d by dx of u by v equals u dashed by v minus u into v dashed by v square, right? Now I'm going to move, so when I write it, I further expand this, I know that my first part of the numerator becomes a u dashed of v, and my second part does not change. It remains as a u into v dashed, right? So that's how we arrive at the quotient rule in differentiation. I hope you found this video and content useful. Please do subscribe to my channel and support. Thank you.